In my last video, we talked about factoring where we did the X method, and that was the undoing of double distributing. Today, we're going to continue that, and then we're going to put together factoring with a GCF and factoring with the X method together to make it all one cohesive type of problem. But before I do that, let's talk about a problem. X squared plus 6x minus 16. So first thing I always want to ask myself is if there's a GCF. There's not. So the next thing I'm going to do is my X method. Negative 16 goes on the top, and 6 goes on the bottom. So I need factors of negative 16. Well, 8 and 2 makes 16. So if I do negative 8 and 2, that's going to add up to be negative 6. So 8 and negative 2, that's going to make positive 6. So I'm done. So x plus 8 and x minus 2. If I go ahead and I look at another one, if I do x squared minus 4x plus 5, oh, and I wrote y, that's good, x plus 5, oh wait, I'm sorry, hold on, that's not going to work, haha. Let's do negative 5x plus 4. First thing I want to try to do is take out a GCF, which I don't have one. I know I don't have one is because that one doesn't have a leading coefficient. Its leading coefficient is an invisible 1. And then this last term doesn't have an x, so the only thing they have in common is 1. So I can try the X method. 4 goes on the top and negative 5 goes on the bottom. So factors of 4, 2 and 2, that's not going to get me 5. Other factors of 4, 4 and 1. Well, 4 plus 1 makes 5, but how do I get negative 5? How do I get a negative sum but a positive product? Well, they both have to be negative. So negative 4 and negative 1, sure enough, make negative 5. So negative 4 and negative 1. And if I do one more before I combine these things, let's look at this problem. X squared plus 6x plus 3. I don't have a GCF, so I'm going to do the X method. 3 goes on the top, 6 goes on the bottom. Factors of 3 are 3 and 1. 3 plus 1, does that make 6? No, those aren't going to work. Do I have any other factors of 3? I don't. So if I can't do anything to this problem, what does it mean? Well, that means that it's prime or it's unfactorable. So if I can't do anything, then my problem would be prime or unfactorable. I don't have to write both of these. I just have to write one, but I have to know what both of them mean. Okay? So now today, I want to talk about combining both factoring methods. Combining both factoring methods. So I have a flow chart of a series of questions that your brain always has to go through. So you're always going to start at the same step. The first thing you always ask yourself, is there a GCF? You can answer that in one of two ways. You can say yes, or you can say no. If you say no, that's what we've been doing, you now do the X method. And then you're done. If you say yes, you're going to take out the GCF, just like we've been doing before, and then you're going to do the X method with the leftovers. Okay? So your X method is always your last resort. That's always the last thing you want to be able to do. So if I go ahead and let's look at some problems. The first problem I'm going to look at is 2x squared plus 6x plus 4. First thing I always ask myself, is there a GCF? 2, 6, and 4. Well, sure enough, they all have a 2 in common. So I'm going to divide by 2. So I'm left with x squared plus 3x plus 2. Here's where you used to be done. But now you're going to take the leftovers and you're going to do the X method. 2 goes on the top, 3 goes on the bottom. Factors of 2 that make 3. Factors of 2 that make 3 are 2 and 1. So you have x plus 2 and x plus 3. But don't forget to bring down your GCF. And now you are done. We go ahead and we look at the next one. 4a squared minus 12a plus 8. First thing I always ask myself, is there a GCF? Yes, there is. What do they have in common, people? They have a 4 in common. So I'm going to divide everybody by 4. So I'm left with a squared minus 3a plus 2. This is where I used to be done, but now I'm going to look at my leftovers and I'm going to do the X method. 2 and negative 3. Factors of 2 that make negative 3. So the only factors of 2 are 2 and 1. So how am I going to get negative 3? Well, they both have to be negative. A minus 2, a minus 1. Does it matter if I wrote a minus 2 or a minus 1 first? Nope, it surely does not matter. But if I circle this, I'm going to lose a point because I don't want to forget my GCF. The directions on all of these problems are going to say the word factor. You have got to ingrain in your brain, every time you see the word factor, your answer has to have parentheses. You're going to get scared of the words, that's what always happens, and you always have to remember factor means parentheses in my answer. All right, let's go ahead and do another one. 3y squared minus 15y plus 18. First question you always ask yourself, is there a GCF? Is there? You betcha. What do they have in common? A 3. So I'm left with y squared minus 5y plus 6. Now I also know I can't do the X method yet because I've never been able to do the X method when y squared has a coefficient. That's never happened to me before. So that's also kind of like a little clue in the problem that if you have a coefficient, chances are you have a GCF, for now at least. So now I'm going to look at my leftovers and I'm going to do the X method. 6 goes on the top, negative 5 goes on the bottom. So factors of 6, 3 and 2. How do I get negative 5 with 3 and 2? Well, negative 3 and negative 2. Done. So y minus 3, y minus 2. If I circle this as my answer, why am I losing a point? Because I forgot to bring down my GCF. Now, what about this problem? P squared plus 12p plus 27. First question I always ask myself, is there a GCF? There's not. I have nothing in common. So here's where on my flow chart I just go straight to the X method. So factors of 27 and 12. So factors of 27 that make 12. Factors of 27 are 9 and 3. Do they add up to 12? Sure enough they do. P plus 9 and P plus 3. Okay, so now what if I had this? Let's see, what if I had this type of problem? 6x squared plus 12x minus 18. So, do I have a GCF? Yes. 6. So I'm going to divide everybody by 6. Now I'm going to do the X method with the leftovers. Factors of negative 3, so negative 3 and 1. That makes positive 2. How about 3 and negative 1? Perfect. Don't forget to bring down the GCF, and I'm done. If I do one more type of problem, I've written it on the screen, 2x squared plus 8x plus 14. First thing I want to do is find my GCF. What do they have in common? Well, they have a 2 in common, so I'm going to divide everybody by 2. So now I'm going to do my x method with my leftovers. 7 on top, 4 on the bottom. Factors of 7 are 7 and 1. Can I get 4 with that? No. So if this was my only problem, it would be unfactorable. But because I could take out a GCF, my answer is not unfactorable. My answer is actually just the inverse of distributing. So the only time I write the word unfactorable is when I can't do anything. So if I give you an example like this. Okay, I don't have a GCF, and I can't do the x method when I have a number here, or if I do the x method with like 1 and 7. Okay, there's no factors of 1 that are going to make 7, so in this example it would be unfactorable. Or I would write prime. Okay, so this is how I combine the two methods of factoring. So you always want to ask yourself, is there a GCF first? If there is, you do it. If not, you do the x method. If you do have a GCF, you do it, and then you try to do the x method with the leftovers. And then that would be your answer.